Hello, class. I want to go ahead and go over um, more of domain 2, and we're going to look at the second part, which is understand linear, quadratic, and higher order polynomial functions. So we'll go ahead and go through a couple problems from there. But again, this is just to give you an idea of what you may see and some topics to go ahead and study a little bit. The NES also offers practice tests that you can take advantage of. All right, so let's go ahead and get to the problems we're going to work on today. So here is the second subsection, and understanding linear, quadratic, and higher order polynomial functions. So I won't read the six that sit here below it, but this should give you an idea of concepts to study. You can see that there's systems of linear equations, solving linear and quadratic equations and inequalities, analyzing the characteristics of linear quadratics. So a lot of stuff to go through here. We'll get just some basics, try to give you a broad idea of what you should be looking for when you see these types of functions. Okay, so let's start here with our first one. Get my pen activated. Okay, so I'll give you a second to read over this or pause me, and then we can get started. All right. So this one gives you a clue. If you read the whole thing, it says set up a system of equations. So we know there's a system going on here. We have to figure out what type of system we're dealing with. So it's saying Thunder paid $18. So let's go ahead and start with the first process and try to set up an equation here. So we're paying $18. I can find my pen. There it is. Okay. So that sounds like a total. So I'm going to put it at the end. And for 3 burgers and 12 fries. Wow, he was hungry. We're feeding a lot of people. So it's given us 2 different variables and a quantity for each. So that's looking like the equation 3 burgers, I'll just use B, plus 12 fries. Okay, and the cost is $18. Another time he paid $12, so there's another total. And 4 burgers and 4 fries. So maybe not quite as hungry this time. Okay. And assume the prices have not changed. So that means the price of the burger and fries are the same for both situations. All right, so we set up a system here, a linear system, and we want to go ahead and solve it to find the price of each. Or you have some options. You could graph these and figure out where they intersect. That would be our solution. You can use substitution. You can use elimination. These are some of the options you can use. I'm gonna go with elimination on this. The reason is the way it's set up. You got your B's and your F's already lined up. Your totals here are lined up. And so I would want to eliminate either the B variable or the F variable, and you're looking for the easiest way possible. So 3 and 4, yeah, we could both get them to 12, but I'd have to multiply both equations. The 12 and the 4, well, all I would need to do is modify this 4 down here to get it to be a negative 12, and then it would eliminate nicely for us. So that's the route I'm going to take, is I'm going to use elimination, and I'm going to multiply the second equation by negative 3. That'll give me negative 12 to reduce nicely here. All right, so I have 3b plus 12f equals 18. And then when we distribute a negative 3 in, I get a negative 12b minus 12f equals negative 36. Okay, so we've modified the second equation so that the coefficients here in front of f's are the same number, opposite signs. Okay, so when I add these, they should eliminate the f. That's the idea here, is to get one of them to eliminate. So 3 minus 12 gives me a negative 9b. Those eliminate, and we're left with 18 minus 36, which is negative 18. Okay, so we go ahead and I'll just rewrite that up here since we ran out of room over there. Going to divide by -9, and that will give us the cost of each burger. So that's going to tell us that each burger is $2. It's a pretty good deal. And now we're going to still need to find the fries. If you want to go down here, we can start eliminating options. It looks like option B is saying the burger was $1.25, so we can feel confident that's not one of the options. Looks like they might be trying to trick us with the fries being $2. Okay, so now we have one of the values of the variable. We can find the other by just plugging in and solving. So I'll just take the first equation that we have, 3b plus 12f equals 18, and I'm going to plug in 2 for the b. So I have 3 times 2 plus 12f equals 18. We get 6 plus 12f equals 18. Subtract 6, and we get 12f equals 12. Divide by 12, and we have the French fries are $1. So we look at our options. This is saying the French fries are $1.25, so we can get rid of that one. So we can say C here. Burgers $2, fries are $1. Remember, you can check your answers too. You could double check that price of $2 and $1 by plugging it into maybe the other equation. So 4 times 2 would be 8, and then plus 4 times 1, which is 4. So 8 plus 4 is 12. So that checks out for us there too. So taking your time, setting up the equation, careful with your steps. Again, you have different options for solving this. This one was set up nicely for elimination, in my opinion, so that's why I used elimination. Okay, let's look at solving the following quadratic inequality. So some things that you want to, again, be familiar with as you go through is understanding the general shape of some of these functions. So quadratic, we should know that's going to create a parabola. That idea that the a here is in front of the x squared is positive, so it's going to be pointing up. And we can work our way through that. So let's go ahead and solve this. And we can find some parts. Usually these be easier to see if you can, if you want to graph them, those types of things, work your way through. But if we want to solve this, we have x squared minus x minus 6, and let's set it equal to 0 and solve. And here you can go ahead and use the quadratic formula. If you remember that, you can use factoring. But we're just trying to find some key parts in our inequality, and we know that the solving for 0 is going to get us on that x-axis. Okay. And our x-axis is our 0 point. So let's see if this factors, since factoring is easier. So numbers that multiply to give us -6 and add to give us -1. Okay. So we can solve both of those. And we get x equals 3, x equals -2. Okay. So if we get a little graph going, start visualizing this, you could also use different parts. Let's see. So -2 and 3. And what we have here is, if you think of this as a graph, if this was our parabola, it's going to open up. So it's going to come through our two intercepts. and a general shape. And so what we're trying to do is we're trying to figure out when the result is going to be negative. So when we plug in maybe 0, what's going to happen? And so we can check. There's sort of three regions here. There's a region to the left of -2. There's a region between -2 and 3. And then there's a region to the right of 3. We want to find out when it's going to be less than 0 or negative. And again, notice the parabola, how it dips between these two values. So let's say we just check 0. We plug in 0. We would get 0 squared minus 0 minus 6 is less than 0. Well, that gives me -6 is less than 0. Okay, that's a true statement. So we should feel good about this region in here between -2 and 3. If we check somewhere outside of it, maybe we'll check 5. We can have 5 squared minus 5 minus 6 is less than 0. So I have 25 minus 5 minus 6 is less than 0. So we have 25, 20 minus 6 is 14 is less than 0. So that's not true. So that cancels out this part. Same idea, if we check over here, we're going to find that it doesn't work over here. And again, you can see the graph, how it's going above. So it's going to be positive values here instead of our negative values. Okay. So we're happy with this region. Remember, there's two different ways to think about that region. You could think about -2 to 3 and -2 to 3. Brackets mean that the -2 and 3 are part of the solutions. No, parentheses mean it's not. So we don't have either option over here. We do. So we can cancel this out, cancel this out. We can feel pretty good. This one's not it. This one we should feel confident since the only one. But if we want to check, let's check -2. And if, it's a true statement, then it would be included, which means there should be a bracket here. But let's see what happens when we check -2. So we get 4 plus 2 minus 6 is less than 0. So we get 0 is less than 0. That's not a true statement. So -2 is not a solution, which means it should have parentheses and not a bracket. Okay. So understanding some of the basic shapes of the functions will really help with figuring out the solutions. Okay, let's look at one more for this subsection. And this one's dealing with the vertex and y-intercept. So again, a quadratic, but we're dealing with an equation here. And I put a little reminder down here at the bottom of the vertex form. So if you see down here. So again, understanding some of these forms that you can get into are good to have so that you can modify your equation to get there. If for some reason you didn't remember the vertex form, this would be something that you can use. Well, y-intercept, you should be able to find y-intercept. So the y-intercept is when x is 0. So we should be able to plug in x equals 0 to find the y-intercept and go from there. So if we have f of 0 equals -5 times 0 squared minus 10 times 0 plus 6. So we get f of 0 equals 6, or the 0.06. That's our y-intercept. So by just doing that, you can get rid of two options. So now you're at least at a 50% chance of guessing if you had to guess, if you for some reason forgot the vertex form. Another, I guess, option would be to put both of these into your equation and see if they actually work out nicely for you. So if they're true. If one of them happened to be false, it wasn't even on your parabola, then you could probably assume the other one was your answer. But let's try to put this into vertex form so that we can see what's going on. Okay. So if you notice with your vertex form, the A value has been factored out of the first two terms, and you have your constant back there in the back. So we need to factor out this -5 from these two terms. All right. So we have f of x equals, I'm going to factor out a -5. That's going to give me x squared plus 2x plus 6. Okay, so all I've done here is just factored out the -5. Now we need to complete the square. Remember, the complete the square is b over 2a squared. That completes the square so that it will factor into a perfect square, which is this portion here. So b is 2, a is 1. So we have 2 over 2 times 1 squared. So we have 2 over 2, which is 1 squared, which is 1. All right, so I'm going to go up here. Now we have f of x equals -5, parentheses, x squared plus 2x plus 1 plus 6, and we have to think about this a little bit. So we added this 1 in here. So if you're going to add 1 to the equation, you would have to do this similar to the other side of the equation. Well, what we are really doing is we're not just adding 1, we're adding 1 times this coefficient. So this is really -5 on this side. So I can subtract 5 off of the other side, or I can sort of skip a step and do the opposite. So I'm going to add 5. If I subtract 5 and add 5 from the same side, that doesn't change the equation. It's still balanced. So that gives me f of x equals -5. I'm going to factor this. So this becomes x plus 1 squared and add 6 and 5. Now from here, we want to be careful. You have minus h here. So a way to think of this is instead of a +1, we want minus something. Well, we'd have to take minus a -1 to really equal +1, right? Negative and negative gives us a positive. So I can modify that to make it look like our form down here. So now I can see that when I go to get my vertex, my h is really -1 and the k is 11. So that little trick right there of remembering that. Looks like I'm missing a parentheses here. There we go. So remembering that if the formula is showing a minus h and you have a +1, it's really minus a -1. So h is really -1. And then we come over to our options and we find. Okay. So just a little refresher on some things. Again, we couldn't cover everything in that subsection, but to give you an idea of what you may see. All right, I hope this was helpful. Thanks for watching.